Okay, let's just look at a piecewise function. So our function is defined, it's the cubic function if x is less than or equal to 1. So basically this is to the left of 1. It's the linear function 3 minus x if x is to the right of 1. So let's just algebraically look at it. If we evaluate the limit from the left, which one of these inequalities puts us on the left? It's going to be this one. So if I was to substitute a 1 in, or something, a very small value close to 1 to the left of it, I would have x cubed, 1 cubed is 1. But if I evaluate it to the right, it tells me that over here, I'm to the right of it, it's defined by 3 minus x, so 3 minus 1 is 2. Left-hand limit, right-hand limit do not match. It does not exist. The limit doesn't exist. It fails one of our conditions of continuous, so it's not continuous at x equals 1. And if we've established that, then we can determine that it's continuous everywhere else. Okay, you may have another type of problem where it tells you to show that f is continuous on the given interval, and we want to be able to show the properties of our definition of continuity. All three conditions are met. Okay, we want to show f of c is defined, that the limit of f of x as x approaches c exists, and that these two are equal to one another. What is f evaluated at c? Now don't let that confuse you. If I told you to evaluate f at 2, what would you do? Everywhere there was an x, you would plug in a 2, right? So same thing. What is f evaluated at c? What? 16 square root of 16 minus c. Okay, so that was the first part. The next thing we want to do is rewrite this as the limit as x approaches c of f of x. We want to show that that limit as x approaches c is equal to, what is this going to be? What is our f of x? The limit of x approaches c of f of x. What's f of x for our particular problem? Good. Square root of 16 minus x. And then we need to say that this is equal to this. Okay, so f evaluated at c. Now, what happens if you direct substitute here? What do you get? Yeah, so if we evaluate the limit as x approaches c, we would get square root of 16 minus c. And therefore we show that. So we would say hence continuous. Let me state that. The limit of f of c exists. The limit of f of x as x approaches c, which in this case is here, exists. And when we evaluate it with c, these two are going to be equal to one another. Okay, next we're going to look at an extension of our intermediate value theorem, which in this case, first of all, if we think back to just intermediate value theorem, so aside from this for a second, if you have f of a and f of b, they had opposite signs, then we knew there was some number c between a and b that f had a 0 at that particular case. Well, if we make a little bit of an extension to that and we say f is continuous, so we have a continuous function here on a closed interval from a to b, it says, and w is any number between f of a and f of b, then there must exist at least one number c in between here such that f of c is equal to w. Okay. Okay. Verify the intermediate value theorem for f on a stated interval a to b by showing that if f of a is less than, make sure you add less than or equal to w, which is less than or equal to f of b, then f of c is equal to w. Now it's wanting us to say that we know that if if w is in between f of a and f of b, then we can find c between the closed interval a and b. So that's what it's suggesting that we do in this particular problem. Okay, so let's get back over there. And our given function for number 12, they'll give us f of x is equal to x cubed plus 1, continuous everywhere. And they only want us to pay attention to the interval the closed interval from -1 to 2 of this function. Okay, the first thing we need to do is we need to determine f of a. Okay, it tells us show f of a is less than or equal to w less than or equal to f of b. So first thing we need to do, let's evaluate f of a. What is our a value? -1. So plug -1 in here. And -1's just, f of a is just going to be what? 0. Okay, what about f of b? Evaluate f of b. That's going to be 2 cubed plus 1. So what's that? 8 plus 1 is 9. What we've calculated is this to be a 0 and this to be a 9, essentially. Okay, and we also know that then it says f of c is equal to w. Let me just write that down. F of c is equal to w. That was told to me. It says, well, if this is the case, then we know f of c equals w. Alright, well, let me take this inequality and write it over here. F of a is less than or equal to w, less than or equal to f of b. What did we calculate for f of a? 0. And what do we have here? 9. So what we want to do is we have a w. F of c is equal to w. So that would give us, what's our function evaluated at c? What's f of c equal to? C cubed plus 1, right? So basically this is just going to be c cubed plus 1 is equal to w. Alright, what are we solving for? We're looking for the c. We're going to look for the c that makes this case true. Solve for c. So let's just algebraically, let's subtract 1. C cubed is equal to w minus 1. And then what do? Take the cubed root, right? Whatever you do to one, do to the other. So c is going to be the cubed root of w minus 1. Okay, let's do another one of those. Same directions for number 12 and 13, but here's our new function. F of x is equal to x squared minus x. And our interval in this case is the closed interval from 1 to 3. Okay, I'll give you a few minutes to try this one. Okay, f of a is just going to be 1 squared minus 1. 0. F of b is 3 squared minus 3, which is 6. So over here, and f of c, let's just evaluate. What's f of c? I'll plug c in there. C squared minus c. So that's just jot down our information. We come over here for this inequality. F of a is 0. So we find out that w is somewhere in between, the value for w is somewhere in between 0 and 6. Now we know that if intermediate value theorem holds, we verify that f of c is equal to w. So we take f of c, which is c squared minus c, and set that equal to w. Now, algebraically, what you need to keep in mind is these are just going to be values. They're just numbers. So c squared minus c, if I move w over and set it equal to 0, we can try to factor that, but what happens if we're not able to factor it necessarily? What's the other thing we can use? Quadratic formula. So we're just going to use the quadratic formula in this case to give us a formula to be able to find c in terms of w, with respect to w. So in this case, if I just use quadratic, a is 1, b is, what do you think? -1, and c is just w, the value w is some number, right? We know it's some number between 0 and 6, but precisely we want this to satisfy any value we choose for w. So we just plug that in the quadratic formula. So I'm going to pause that and then you can check your answer. Okay, first of all, correct. Our C is going to be negative W. So this is just going to represent a value of a number. When we plug that in our quadratic formula, we're just going to get our C. We can find any number C that's going to verify our intermediate value theorem for this particular problem with this formula.